Okay, so we have three different concepts that we are testing over. Similarity of three-dimensional figures. There is functions, right? Geometric and algebraic functions. And the last one is probability, which most people seem to get pretty easy. So we'll do that last.
We're not doing the algebra stuff?
Okay, scale factor. Okay, so we're told in number one that we have some similar quadrilaterals with a scale factor. Okay, and then we're told something about the perimeter. So if we're going to calculate something's perimeter, which ratio do we need to know? We need to know the scale factor. Scale factor is a linear distance. Perimeter is a linear distance. So we're going to set up our proportion with the given scale factor. So 1/3 is your proportion. Right, that's the ratio that we want for this. And it says the smaller quadrilateral is 30. So that goes on top, and we're looking for the perimeter of the larger quadrilateral. Right, so I have smaller stuff on top and bigger on bottom. So 30 belongs to the smaller, and we're looking for the perimeter of the larger. So we solve this by simply cross multiplying. So the perimeter of the larger quadrilateral is 90 centimeters. Okay, pretty easy when we're given the information that we need. Okay, number two says that the edges of a large cube are 2 times longer than the edges of a small cube. So what is the scale factor? 2 to 1, right? So now we're doing large to small. The large one is twice as long as the first. That is the scale factor. It's talking about the edges. If the volume of the larger cube is 30, what's the volume of the smaller cube? So if we're trying to find volume, what ratio must we know? The volume. So we have to cube both of these things. So 2 to the third power and 1 to the third power is a volume ratio of 8 to 1. So our volume ratio is 8 cubic units to the large over 1 to the small. So that's what we're going to use to set up our proportion. 8/1, or 1/8 if you want to put the small thing on top always. But 8/1 equals, the volume of the larger is 30. So 30 over V. 30 over V, the volume of the smaller. So once again, we solve this by cross multiplying. So 8V equals 30. And when we divide 30 by 8, we get a volume of 3.75, and the units are just cubic units. Okay, in this next one we have our scale factor of 2 to 5 is the scale factor. And we said the smaller cylinder has a surface area. So if we have an area, what do we do to our scale factor? We're going to square the scale factor. So 2 squared and 5 squared is 4 to 25, right? 4 to 25. So this is going to be our proportion, right? The ratio we use in our proportion is 4/25 equals, the smaller has a surface area of 78 pi, and we're looking for the surface area of the larger. So if you want to write SA, that's okay also, or A will be just fine. So we cross multiply, and hopefully you have a calculator to do this. 25 times 78 pi, and then divide that by 4. And we can get that as a decimal, I'm sure, when we do 25 times 78 pi divided by 4. 1531 and change, so point something 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 square meters. Okay, and our last one on this problem, we have actual volumes of 54 and 16. So 54 is the volume and 16 is an actual volume. Okay, so before we go ahead and change this to a surface area, a scale factor, is 54 a perfect cube? And the answer is no, it's not a perfect cube, which means you should not be cube rooting it. You should be reducing it. We should always reduce before you root. 54 is not perfect cube, and neither is 16, but they both have a 2 in common. So when we divide them by 2, we get an actual volume ratio of 27 to 8. Now 27 is a perfect cube, and 8 is also a perfect cube. So now we can figure out what their scale factor is by taking the cube roots of these things, and we get a scale factor of 3 to 2. The cube root of 27 is 3, and the cube root of 8 is 2. Now, we wanted an area, so we're not done yet. We need to take our scale factor and change it into an area ratio by squaring both of your terms. So 3 squared and 2 squared gives us an area ratio of 9 to 4. And that's what we're going to use in your proportion. 9 over 4 equals the area of the smaller solid is 22. So because 4 is in the denominator, the 22 will also be in the denominator. And we're looking for the surface area of the larger figure. Okay, so here we have to do, this is the hardest type because it has all the things. Right? We have a volume that you have to reduce before you root. And when you cube root it, you get the scale factor. But because we want area in your problem, we change your scale factor into your area ratio. And once we have your area ratio, we can set up the correct proportion. And now the math says cross multiply and divide. And when we multiply 9 times 22 and divide it by 4, we get exactly 49.5 square units. Okay, switching topics. Now we have our function notation. So we want to express the area of a circle as a function of its diameter. So this is where we have your two equations. First, of course, we have your area of a circle equation, pi r squared. And then we have our diameter equation. So what does the diameter need to relate to? The diameter needs to relate to the radius. We have r in your area formula, which we don't want to have anymore. So we need to find a relationship between the diameter and the radius. And for every one diameter, there are 2 radiuses. Right? A radius goes from the center to the edge, and a diameter goes from the edge to the edge through the center. So the diameter is 2 times as long as the radius. So over here in our red equation, we're going to solve for r. So the radius is half of the diameter, right? Which makes sense. If you wanted to know the radius and you had a diameter of 10, you would divide it by 2. The radius is half of the diameter. So now we're taking this equation and we're moving it back over to area. Pi times diameter divided by 2 squared. We are replacing the radius in your area equation with half of the diameter because the radius and half of the diameter are equal. Those are the same measurements. So we can replace them when they're equal. So now I get to simplify. When I simplify this, I need to square the numerator and square the denominator and then write it as a single answer. So that would be pi times diameter squared divided by 4. So the area of my circle as a function of diameter would look like that. Okay, so I don't have to convert from diameter to radius. I can go directly from diameter to area. Okay, so that's what we're doing with these problems. We are figuring out 2 different equations that match them up. So perimeter of a square as a function of its diagonal. So let's draw a little square so we have a visual. Okay, what variable do you want as the side length for your square? All right, S's look like 5s, but whatever, that's your beef. That's your beef. Those are all S's. Those are all S's, like we said, S. So the perimeter of your square is equal to 4S, 4 side lengths. Right? S plus S plus S plus S is 4S. Now, what about the diagonal? Right? I need to find a relationship between the diagonal and the side length. And what type of a relationship exists between the diagonal and the side length? That would be a Pythagorean. Yes, a Pythagorean relationship, because we have a right triangle. So we know that S squared plus S squared equals D squared, where D is the hypotenuse of that right triangle. And since we want to get rid of S over here, I have to solve for S in my Pythagoras. Okay, so this is 2S squareds. Right, we divide both sides by 2, and 1S squared equals diagonal squared over 2. And my last step would be to square root. So I get this really not attractive but perfectly correct equation. Right? It's not very good looking. It's a square root of a square divided by a number, right? So this is your side length. We're going to take that number and put it back over there for S. Now the tricky part is there's really nothing we can do here. So 4 times the square root of diagonal square divided by 2 is all we can do. Okay, there's nothing to simplify there because there's no algebra that will cancel out the squares and the square roots and none of that stuff. So that's what your answer looks like. As unattractive as it may be mathematically, it is still correct. Okay, and then the one we've been working on a lot recently, this radius, or rather a cone with its vertex down, right? Expressing the volume of a cone as a function of its height. Okay, so we have a couple of steps. The first step is always to start with your volume formula. 1/3 pi radius squared times h. And since we only want to have h in our equation, we need to get rid of your r. Okay, and we've done that every time by making a ratio. We are comparing the radius to the height. Right? In any cone, there are right triangles where this is the radius and this is the height. So as the height decreases, the radius decreases in proportion. Okay, because these are similar triangles, they're right triangles. That's why we have a proportional relationship. So we're going to go back to the maximum. So we have a radius of 8 when the height is 6. That's what we know. The radius is 8 when the height is 6. And we're going to solve this equation for r. So we can cross multiply, right? This is the easy way to do it. I guess easy, but 6h equals 8r. Nope, switch that. 8h equals 6r. Divide both sides by 6 and reduce. So what does 8 over 6 reduce to? 4 over 3. 8 and 6 both have a multiplier of 2. They're even numbers, so we can divide them both by 2. Now I'm going to take my 4h over 3 and put it over here. Right? So this is your step, right? We have set up our proportion, we have solved for r, and now we go back and we substitute. So 1/3 pi times this thing squared times h. And that was 4h over 3. So we found our volume formula, we made your ratio and solved for r, and now we have substituted. So now the hard part is simplifying. So we're going to square all of these terms here, this 4, the h, and the 3. We're going to square all of them. Okay, so we still have your 1/3 in front. We still have pi, but now we have 16 h squared divided by 9, and we're still multiplying that by h. So our last step is to finish this one. So I multiply my denominator of 3 by my denominator of 9. And then everything else is a numerator. So 3 times 9 is 27. And 16 pi h cubed on top. Okay, so our last one here that we're going to do on this video is this algebraic function one. Okay, so we have a triangle, right? We're told that we have a triangular figure, that's good, formed by 3 different lines. We have the x-axis, we have this relation, right? This linear y equals 2/5 of x, and then we have a vertical line, some random vertical line that's out there on your graph. Okay, so remember, this is how we're going to sketch this. We start by the x and y axis, so we have an x-axis that goes horizontally, and we have a y-axis that goes vertically. Okay, so we're going to graph y equals 2/5 of x. Right, this is our linear equation, your algebra 1. This has a y-intercept of 0, 0. There is no plus b, right? Y equals mx plus b. There is none of that in this equation, so we have the origin as the intercept. And then we have a slope of up to and right 5. So you go 2 units up and 5 units to the right. And that's where we put your first dot. Okay, in fact, that's really the only dot we need. But if you want to be more precise, we can go up 2 more and right 5 more. And that's how we get another dot on your graph. So we have that, right? That's the line, y equals 2/5 of x. And then we have some other random point, x comma 0, which we don't know what x value is, right? This is some random point, which is why I don't have any tick marks on my axis, because I don't want to think it's something specific. Okay, that's the vertical line. So yes, here's your triangle that is formed by these 3 lines. The x-axis, the vertical line, and the blue line, 2/5 of x. Okay, so we want to know the area of that triangle as a function of x. Right, so this is your basic triangle. The formula is 1/2 of base times height. Right? That is your basic triangle formula. Anytime we have a right triangle, that is exactly what we want to use. So what is the base length for our triangle? Right, the base length is the horizontal distance, which is always an x unit. So the base is given to you by the x value that you pick. Whatever x value that is, that gives you the base length for your triangle. And what about the height for your triangle? Well, that's the red letter, right, from here to here. And what is this length? This is your y value, right? Anytime we have a vertical length, we're looking at a y value. And how do we calculate all of the y values for this graph? You multiply x times 2/5. So the y value, or the height of this graph, is always 2/5 of the x value. So if I had an x value of 10, right, that would have a y value of 4, because 4 is 2/5 of 10. But we don't know exactly what it is. Oh, I guess we will in a minute, huh? So let's simplify this equation so we have one nice thing. So all of our numerators, 1 times x times 2 times x is 2x squared, and your denominators are 2 and 5. 2 times 5 is 10. Can I further simplify 2 over 10? Yes, to x squared over 5. Now this is the most correct answer, But yes, 2x squared over 10 is also correct. It's just not as correct, right? If you left your answer as 2x squared over 10, I would be completely satisfied that you know what you're doing in simplifying this equation, right? You would have convinced me. So then the last problem, what is the area when x is 10? Well, I have a formula for that. That would be 10 squared divided by 5. 10 squared is 100. 100 divided by 5 is 20. So this triangle, when x is 10, would have a 20 square unit area. Okay, so those are some things that we've talked about before that will end this video. Okay, so the next page will be on the next video.